Hello student, welcome back. I hope you are doing well. Today class will see about the one component system of water. That is, a water system will be discussing water. As you know that this water has it is a chemical formula H2O. And this water, it exists in a solid also. Solid, it is in ice form. Water can also in the liquid form, and water can also exist in the vapor phase. So these are the three phase: solid, liquid, vapor phase. Water exists in the three phase. So in water system and the phase equilibrium, we have discussed about the degree of freedom. So this degree of freedom is represented by F C minus B plus 2, that you know. This, whereas this C is the component of the system, this is the component, it is a component, and this P is the phase. So just keep in mind that water has a three phase: solid phase. Water can also act as solid, it can also act as a liquid, it can also act as a vapor phase. So water can exist as a three phase. Okay, so this is the one component system diagram. If you see here, it is a temperature. It is something like this: temperature versus pressure, right? Temperature can be in the Celsius and it is in the atmospheric pressure. So temperature versus pressure. This point is a zero, a triple point. This where from A to O to A is a vaporization curve. From this O to B is a sublimation curve. O to C is a melting curve or fusion curve. So this is the ice. That is a ice is a solid, and this is a liquid phase. This is a so if you consider from this point 0 to A, it is a vaporization curve. From this O to C is a melting curve, or it is a, let me write here, melting or fusion curve also you can write. So this point, from this point to this, is a sublimation curve. So solid, this part, it is an area. From this O, B, C is a one area. A, O, C is another area. A, O, B is one area. So you have a three area gaseous state, that is a vapor phase area. It is a one phase area, liquid, and a solid area. So here, water system, you have to know about we are going to study about the significance. So the significance of this water system, as I've told, significance of water system, that is if you consider a curve, if you consider any curve, it can have a like a you have a, say you have a melting curve or any curve. It can have a curve like from OA, OB, OC. This is it. OA is a one type of curve. OA, it is a vaporization curve. OB is a sublimation curve. OC is a fusion curve. So all this, any of this curve, any curve, it can have any of this curve, it can have a degree of freedom. So if you consider, suppose we have this melting curve A, O, B, C. So if you consider a curve, as you know that this part is solid, liquid, and gas. So from this curve, if you consider from liquid to gas, it can have a two phase, right? So degree of freedom equal to, we are considering for one component system is water is 1, minus, if you consider for OA, it can have a two two phase. It can have a 2 plus 2. So f equal to 1. So for any curve, any of this curve, any of this curve, OA, OP, OC, degree of freedom will be 1. That is monovariant. So all of this curve, that is OA, OP, OC, this degree of freedom will be 1 for the curve. So area, if you see for the area from here, so let's say area of the curve, area, if you have the area like you have a solid liquid case, so let me write here AOP or AOC, it is a AOC, it is a liquid phase, AOC, or you have a AOP, it is a vapor phase, AOP, vapor, or you have a POC, it is a solid. So if you have any of this, you are considering for the AOC is a, say you have a liquid, AOP is a vapor, it is a solid. So in any of this area, if you consider, you have a degree of freedom will be C minus P plus 2 will be how much you will get. Component is 1 and P is you have only one phase, solid phase. If you consider for this AOC area, you have a liquid phase, you have only one phase plus 2. So 1 minus 2. So this F equal to 2. So for the area, any of the area, if you see for the area, like if you consider for area, it is a pi variant. You have a AOC, AOP, POC. All this area you have a degree of freedom will be 2 in case of water system, right? In case of water system. So for the melting point, you have a melting point, or that is a melting point or triple point. You can have a right triple point is 0. So this triple point is a point where all the at triple point this degree of freedom will be C minus P plus 2 will be, since you are considering for the temperature and pressure, this triple point where all this APC is meet, that is a solid, liquid, vapor, all these three meet at the point, that is a, so you have one component, and since all are meeting, you have a, how many phase will be? 3 phase. All these 3 phase are meet at the point. So this degree of freedom will be, you have a 3 minus 3 equal to 0. So at triple point, this F equal to 0. For the water system, the triple point will be, for water system, the triple point is 0, because this is a non-variant. It is a non-variant. So these are the 3 main important significance, and we have another significance that is called a metastable. Metastable state. Sign down. Oh yes, so this 4 point will be the metastable state, metastable. So if you have if you watch in the curve, suppose you have this curve, as I've told, this vaporization curve OA, it passes through this direction, and thus OA thus, it will be OA thus. So this point is a supercooled supercooled. It since it is a metastable, it is unstable. It can be reversed back by adding some ice in the solution. So these are the four significance of this. As I've told, the curve OA OP, OC. OA is a vaporization curve, OP is a sublimation curve, OC is the fusion curve. So all these curves you have a degree of freedom will be 1, that is a monovariant. For the triple point, it is a F equal to 0, that is F equal to 0 occurs when this all the OA, OP, C the point, this triple point 0 point, it occurs at such temperature 0.0078 degrees Celsius temperature and 4.68 this much atmospheric pressure. When this temperature and pressure occurs, all these three liquid, solid and gas water meet at the point. This point is called triple point. And this OA, it passed through this state. OA pass through. Since it is a metastable state, it can be reverted back by adding some ice water in the solution. So these are the four types of. And this water system, if you see the curve, this curve, it should be in the straight line, but why it went to this direction is when the solution, this temperature and pressure, it is in water system, Tp by Tt is negative because due to decrease of the volume, decrease of the volume in the solutions of the phase. So these are the three few important significance. I have attached the PDF files, so you can go through it. So that's all for this video class. Yes, that's all. Thank you everyone for watching the video.